So the reason this worksheet is laid out cylinders, cones, and spheres, and probably you guys have already memorized the formulas, is that if you think about the formula, those three shapes have a very similar, like if you're looking for a pattern and ways to memorize the formula, I've taught it one time like this as well. So remember, any prism or cylinder is big BH for a cylinder. And then we know that a cylinder has a circular base, so that's pi r squared h for the volume of a cylinder. And then to make a cone, and this sounds really silly, but for cones and pyramids, so I always think about cones as those water cups out on, if you're on a school trip or something, those little snow cone cups, water cups is kind of what I think about, the white ones, and you see them and they're always stomped everywhere, and all of a sudden they become a triangle. And a triangle has three sides, and this is a little bit of a stretch. But so when I think about a cone, it's the cylinder, but I pinch the top, and it's three sides, so it's 1/3 pi r squared h. And so that's your cone. Anything is 1/3, and then same with your pyramid. You pinch the top, and obviously if it's a square base, it doesn't make a triangle, but ultimately, again, you're pinching the top, so it's a three-sided figure, flat-ish. So that's where the 1/3 sticks in my mind. And sphere is just weird enough that in my brain that it's 4/3 pi r cubed h. And again, because you guys are here, just to let you know, lots and lots and lots of people miss this formula because of the cubed. Because we're so geared and wound to do pi r squared, the pi r to the third power. And sorry, minus h, there is no h, as I'm looking at that again. But the third to the third power messes everybody up on sphere. 4/3 people end up getting, for whatever reason, it sticks. And I think it's more just a rush than it is that you don't know. Like you're just boogieing straight through and you're used to pi r squared. So if you can, in your brain, remind yourself it's pi r cubed with the 4/3 in the front. But that's why this worksheet is laid out with these three shapes, because their formulas have a lot of commonalities and a little easier maybe for people to memorize that way if you work them all together. So the shape in the formula for this guy, we're going to have a cylinder. And like we said, the volume formula for a cylinder is the area of the base, which is a circle, so pi r squared, times how many slices of bologna, or the height of the cylinder, is volume. So here the volume is given. It's in terms of pi. This is another thing that really rocks everybody's world. In terms of pi, and all that means is don't push the pi button. Don't use 3.14. So you do all the math around it, and then honestly, you just tack on pi at the end. It's really a gift because it keeps you from having to use decimals. And if you're combining composite figures, it makes things a lot easier because then they're more accurate as well. So in terms of pi means the pi button is never pushed, and pi is present. So 72 yards cubed would not be accurate. It's 72 pi, because remember, pi is a number, and that is that 3.14 indefinite irrational number. And again, as we discussed last class, the more decimals, when they start to multiply in, and most all volume is multiplication, it makes a big difference. So you don't want to toss that pi out. So in this case, we have our volume and we have our height. So we're missing our radius, because ultimately that means we have our height and we have our volume. And the only other unknown in our formula is our radius. So the volume would be this guy, obviously, just to call back out, and our height of 8. And so we're missing radius. So back like 8th grade math, or I'm not really sure you know how long ago, but it was a long time ago. So it may not be in the forefront of your brain. You're just plugging things in. So volume, we're going to use 72, and we're going to go ahead and use pi just for accuracy. It's equal to pi. And the cool part is, as soon as you see pi on either side, they're going to make each other go away. They'll undo each other anyway, because this is all multiplication on this side. We don't know our radius squared, so I'm going to put it in kind of parentheses. And then our height is 8. So things over here with the r that we want to get rid of would be the pi and the 8. You can do them one at a time, or they're both attached by multiplication, so we can just divide by 8 pi. Beautiful when we see pi's on one side like this, on top and bottom of your fraction, because they just go away. So at that point, you have to do the math of 72 divided by 8. Can you guys tell me what is 72 divided by 8? Yeah. So 9 equals radius squared. The inverse operation of squaring something is we're going to take the square root. And as we talked about in prior answer, there are two answers, a positive and a negative, but the length of a radius can't be negative. So our radius is going to be 3. Ta-da! The biggest thing is just making sure you work inverse operations in the right order. And as always, just slow down. As long as you're going slow enough to think about what you're doing, hopefully this should be an easy unit. The grades never reflect an easy unit, but I think that's, again, back to that whole like memorization and the slow down part. All right, so we have a sphere, which is 4/3 pi r cubed equals volume. What do we have? So we have our volume here, again, in terms of pi. So volume we do not have our radius or our diameter, because in this case, we're solving for diameter. So that would be your other big call out. If this was a multiple choice question on an EOC from the state, they're going to have the radius in there for sure as a choice, because that would be your, like, what I call your dummy answer, that moment where you're like, oh, I knew better than that. What a big dummy. I know what I'm doing. So again, not like when I say that, I'm not trying to call you a dummy. Just that moment, like, blind moment. I don't know how you want to like call it where it's not offensive. But so that would be your, make sure you're paying attention again to what you're solving for. So what is missing in this case, or what we're solving for, would be your diameter. As far as what's missing from the equation is your radius, because we have our volume. Pi is a number, 4/3 is a number, and so we're just now looking for r cubed. Again, make sure you're paying attention to the r cubed part. Now, your choice how you want to write this, because it can be 4/3 in the front or all over 4 times. Our radius cubed, we don't know what that is, equals, and our volume is 288 pi. Depending on how you write it, you can do it in a little slightly different, all different kind of orders. You could, if you did it the way it's 4/3 over here, you can multiply both sides by the reciprocal and take care of that all in one foul swoop, which probably, if you're trying to do things in a fast order, it would end up being 3/4 pi that you would multiply this side by. But if we're going super basic and one thing at a time, we're going to multiply both sides by 3. Hey, Logan. And then, so our 3's are going to go away on this side. I have no idea what 288. We're going to leave it in terms of pi, again, just because it makes it easier. So 288 times 3 is 864. So now I have 4 pi radius cubed equals 864. Don't leave off the pi, because again, for the 145th time, it is a number, so it can't go away. Now, just like the one prior, we're going to divide by 4 pi. Divide by 4 pi. Again, big yay, you see those pi's, there's no math, that's gone. So it's radius cubed, and that's 864 divided by 4. 216. We're not quite done. Radius is not by itself. It is cubed, so to the 3rd power. So this would be another place where people make oops mistakes. Not like I didn't know that, but oops, like, oh man, I was just on a roll. Instead of taking the square root, you're going to take the cube root. In Desmos, it's in the functions, and then you scroll down and find it. In a TI-83 or 84, and Logan, just especially because you're here, we are getting TI-84s. They're going to get downloaded to your computer, I was told, fairly soon. I know you already have one, but so we'll be doing a little more instruction with that as well. A big conversation. But it is under math, and it is getting number 4, 216, and you guys probably have already found that. But so the cube root of 216 is going to be 3. So radius equals, oops, sorry, I'm making that up, 6, not 3. Nothing about that says 3. Cube root of 216 is 6. Now, like I said, if this was a multiple choice question, that 6 is definitely going to be there. That is not our answer, because it is asking for the diameter. This is the radius, so the radius is equal to 6, and diameter is 2 times your radius, so it's going to be 12. So the answer to this question would be 12. Everybody hanging in there so far? So good? All right. Cone. Remember, it's still pi r squared h, but it's pinched at the top, so you have 1/3 or all over 3. And that is going to equal our volume. So if we look at the things we have, it looks like we do have our volume. This time it is not in terms of pi. So that means they already used the pi button. Not always ideal, especially if we're not super, super great at, what's the word I want to use? Rounding decimals. Radius, go right here. And then our height is our unknown. So height is what we're missing. So we're missing the height. Using our formula, we're going to plug in what we know. Our radius is a 3. If we don't know our height, divide everything by 3 or multiply by 1/3, and our volume is 75.4 centimeters cubed. Now, also, another call out, because I know this is a big call out by Ms. Lynch for science. Measurement matters. So the 6, because it's meters squared, meters cubed, this is meters. Flat line. So it's not cubed, it's not squared, it's a flat line we're measuring across. Same up here, our radius is going to be yards because it was yard cubed. This is 8 yards, so our radius should be 3 yards. And our call out and discussion was that you want to make sure you're paying attention to that, those units of measure, especially, I haven't seen it happen a lot in Math 3 questions, but in science, apparently it's a big thing. Like they give it to you in inches, but they want the answer in feet, or they give it to you in feet and they want the answer in yards. So make sure you're paying attention to that too. Not really pertinent to this worksheet, but just call outs from other teachers of things that we can discuss and maybe make better in their class as well. So we want to get the 3 off the bottom, times both sides by 3. Those go away. 75.4 times 3. Wish I could do that one in my head quickly. So now I have pi. We can go ahead and make that a 9 because 3 squared is 9. Times height is 75.4 times 3, which is 226.2. Now again, you're looking at what we can get away from that height because we're solving for height. So we can divide by 9 pi, divide by 9 pi. Not something you can cross out super fast or do in your head at this point. So 226.2 divided by 9. And I'm going to use the pi button. Like I called out on Monday, use whatever they're telling you to use. If they tell you to use 3.14, then use 3.14. If they tell you to use the pi, then use pi. If they don't state one way or the other, they're probably, and I say probably because every time I go hard in the paint on anything like this, it bounces around. But 9 out of 10 times, if nothing is said as to using 3.14, use your pi button. So use the pi button, which hopefully we already know this, but it's second and up caret. So right underneath the clear button on your TI 84s or 83s. And then in Desmos, I'm pretty sure it's right there down at the bottom of the calculator in the numeric section. So if we hit enter, we have a lovely, nasty number that does not work because I put that in wrong. Good. Phew. I was like, that can't be right. 0.2 divided by 9. Try that again. 9.41. And we'll go 2 decimals. Again, that's one of those things. Do whatever they tell you how far to go. I personally, 2 places is plenty. I'm not a 1-place fan because multiplication, and to be honest, we deal with pennies every day, so I'm not sure why we ever made that a thing to only go to tenths. But for accuracy and make me happy, I go 2 places. And then this is just centimeters because it was centimeter cubed because that's 3-dimensionally. You're like pouring water in your cone or ice cream in your cone. The height of the cone is not 3-dimensional. It's only flat and 2D. So then there's our height of our cone. Cylinder again, but now we're missing a different part. So cylinder, again, our formula for cylinder, pi r squared times the height equals volume. Pi r squared, again, being the base of volume. So that's for all prisms. A cylinder is a prism. It's just circular. I'm probably over talking, but again, just sharing. So the volume of that circle on the bottom is the pi r squared. Then our height is how many slices of bologna, which is so gross when I say it, but it always makes me kind of giggle, is the height. So how many sheets of paper, slices of bologna, provolone cheese, whatever it is that makes you like remember it. There are stacked in this column. And then your volume here in this case, again, is going to be 54 pi. And that's in terms of pi, which meant you do not use the pi button. It is a number, so it's not dismissible like a measurement. Or, I mean, like I said, measurements are not supposed to be dismissed either. As far as accuracy for numbers, though, pi will really, really, really jack your world up. Don't lose it. So in this case, we're missing our height because that's where our x is. 6, it has drawn all the way across, so be careful as well. This is a diameter. We don't use diameter for this formula. We use radius. So if the diameter is 6, then our radius is going to be 3. And I'm writing that down because I have the attention span of a squirrel. So not only do I rush, I don't pay attention to small little things. So I have to write those kind of notes all the way through to keep myself straight. So I do highly recommend doing that. Our diameter was 6, so our radius is 3. So radius squared. Our height is unknown. I'm going to leave it an h, but you can plug in an x if you want. Equals 54 pi. And that was centimeters cubes. Again, just the name of Miss Lynch to make sure we're discussing our measurements. I'm the world's worst at ignoring it myself. So pi 9 height equals 54 pi. And maybe I'm just a super nerd. I love it when it's in terms of pi because it just makes it so nice and neat. So divide by 9 pi because, again, pi, go away. 9's go away. 54 divided by 9. My paper's dragging. 54 divided by 9 is going to give us what? You guys tell me. I like that one might be an easy one. 54 divided by 9 is... Yes. I love it. Thank you for never leaving me hanging. So the height in this case is equal to the width of this cylinder. It's a lot of baloney in theory if you eat baloney. So height is 6 centimeters, not centimeters cubed, because cubed is 3-dimensional. Centimeters, again, is your flat measurement. We have another cone. So we're looking at a cone. Again, our cylinder is pi r squared height. Cone, we pinch the top, so we're going to divide by 3 or multiply by 1/3. Well, you guys tell me, what are we missing? And hopefully you can tell in this picture. It's a little scratchy. Height, radius, or I guess volume is an option as well. Yes, good job. So volume, as I said it with like smirk in my voice because the worksheet is laid out this way. And then our height is our 12, so we have that. And then you're missing the only other variable, which is your radius, which is right here. It's your x. Yep. So we're missing radius. Now we're just going to plug in. So pi, radius squared, unknown. Our height is 12. And I know for some people that messes people up when it falls on its side. At the end of the day, it's still an ice cream cone, no matter how they stack them. What is the height, depth, whatever. I mean, whatever word you want to use, it doesn't change. Like, even though it's on its head, like turned upside down, sitting straight up full of ice cream, laying on the side, the height of the cone itself is still the same place. Equals 16 pi. So again, Sigmund nerd happy status. It's in terms of pi, which means they just didn't push that button or multiply by 3.14. We are going to, we need to get rid of our pi and our 12. We can do it in one foul swoop. Ooh, this one's ugly. Not fun. Oh, I messed up. Good. I was going to say, that's even uglier than I thought it was going to be. I left out the important part. We pinched it. So we're going to divide by 3 on this whole formula. Or multiply by 1/3. So before we divide this 16 pi, we are going to multiply both sides by 3. Or that's the same thing as multiplying by the reciprocal of 1/3, because 3 over 1 is the reciprocal of 1/3. So then we're going to do 16 times 3, 48. So pi r squared 12 equals 48 pi, because the pi is still there, just 3 times 16. Now we're going to divide by 12 pi. Big yays, all our pi's go away. 12, 12, pi, pi. So now 48 divided by 12 is what? You guys tell me. Yes. And r is not by itself. What is the inverse operation of squaring something? You know what the inverse? How do we undo r squared? And r squared is asking, or I guess the operation is stating r times r equals 4. So since it's r, yep, you're going to square root both sides. So what number did I multiply by itself twice to get 4 is what I guess we're asking ourselves. Or, like I said, easy square root. R equals 2. It is plus and minus 2, a square root as algebraic, but we don't use the negative for measurements. Also, if you have a calculator, again, you've probably figured this out already, but x squared, it was always one of my favorite operations because the inverse is on the same button. You just have to hit second. So they are on the same button. The inverse of squaring something is rooting something. The inverse of rooting is squaring. So our answer is going to be 2, and our unit of measure was centimeters. So 2 centimeters for a radius. That is a super tiny cone. I don't know where we're using that. Yep. Good job, Abby. Thank you. All right. Last but not least, we have another sphere. Need more coffee. Sphere. So we have pi r cubed, no height, and then 4/3 in the front, or 4/3 for the whole thing. We have our volume. We do not have our radius. So we're looking for our radius. Everything else is numbers, so we're all good there. So we are looking for radius. So we're going to do 4 times pi. Our answer is given in terms of pi. Radius cubed equals 288 pi. Kilometers cubed, fun new measurement, all divided by 3. We're going to multiply both sides by 3 to get it off the basement, or out of the basement. Or, again, you can multiply by the reciprocal. So 3/4 pi, if you want to do it that way. 3's are gone. 3's are gone. Oh, that's not right. Yeah, 3's are gone. This is not supposed to be there. Wow, I'm going down a deep rabbit hole. Sorry, guys. So 288 times 3 is 864, which we've already done. Is it the same problem? It is the exact same problem, except I'm asking for a radius instead of for the diameter. Whew. Now you're going to divide by 4 pi. 4 pi. Pi's go away. 4's go away. Radius cubed is 260. Undo cubing something. We take the cube root. Again, be careful not to square root. It is cube root. Again, it is in functions on Desmos on the calculator. It's over at the top right-hand part, and you can scroll through. Or it is in Math 4. Whoops, I'm too high. Math 4. You see it. So if we take the cube root of 216, on our previous problem, the radius equals 6 meters. And in this case, that is the answer to this problem, is 6 meters, because it's asking for a radius, not the entire diameter like the one prior.